want to grab a seat. So here we have Randy Marquardt. This is actually my first time working with Randy, but we've worked with SEG for a long time. They do work on the building envelope. For us, they've acted as consultants for roofs, roof replacements, roof inventory. They do that, they provide that service. And tuck pointing, anything having to do with the building envelope. So what that is going to be presenting, and I really don't know what this whole presentation is about, but hopefully it's going to be on ways and the latest methods and needs on how to maintain our building envelope. So take it away.
Right here. I've been around forever, so coming up here on 33 years in the business.
Nice.
Before I ever graduated from architecture school, I was working in this kind of stuff as a consultant. So I have been on your projects before, but you just don't see me because I'm in the background in the office. So I've done the field work, I've done CAD work, and for the last about 20 years or so, I've been essentially design manager. And the great thing about that is I get to see everything everybody in our company is working on as it comes through the process in terms of reports or problems, or, can you help figure this out, to, here's how we're redesigning it and putting it out to bid. So the company, especially engineering, is the SEG part of the SPR SEG, and so it's our Milwaukee and Madison offices. We're also in Illinois and Indiana. So just looking at the topic of the presentation, I came up with sort of a let's do a quick historic review of, buildings in general. If you look in the ancient times, buildings were very much built out of stone. They were, meant as, documentation of history. They were symbols of power of the country that was doing them or whatever. As we got into the Middle Ages, they became more utilitarian, again built with materials that were at hand. At some point in time, I threw Notre Dame under because of the recent fire issue, but it is a great example of the technology at the time of engineering, of architecture, of building construction being pushed to its limit. And the soaring heights and the technology of keeping it from collapsing were very important at the time. As we, develop buildings in America, you see some of the same kind of things. You see stone buildings, very important to, longevity, to making a statement about your place in the country, in history, whatever. But then, as technology grew, as architectural fashion sort of changed or whatever, we started getting, concrete buildings like this that came up. We get glass walls. We get, more different materials and technology and things. And obviously, we are also pushing the limits of our technology at all times. So we've got Frank Gehry making crazy things because this is possible now because of computer structural analysis of fabrication technologies and things like that. Same with engineering, being able to build, spans and clear openings. This is Apple's headquarters. Their whole concept basically is that it's flat floor slabs that allow for all essentially open space, glass walls. And then obviously as we go forward, people are looking at green technology and the idea of, bringing vegetation and plants and everything into it. We're also seeing that in roofscapes, obviously. People want to use parts of the building that they haven't ever used before and use them in different ways. Plazas, green space, or decorative. So current building materials, still using stone, still using brick masonry, combinations thereof. Again, concrete, steel, glass, structures age, we're seeing problems with those. You have, like this one, the fashions of 50, 60 years ago are now being reanalyzed and saying, well, that wasn't, energy responsible to be doing that. So now we're having to go back and look at retrofitting a lot of these things, figuring out where this project was, again, steel structure going right through a single pane glass curtain wall, or obviously needs to be updated. And then on the other side, you see the driver of cost coming into play. As you need facility space and stuff, you don't always have the ability to build it with concrete and stone and masonry, that kind of thing. So we see, obviously, stucco coming into play as well. Not as long lasting, but again, depends on what you're trying to accomplish. And as we go forward, we're seeing also new materials developed and how those are being integrated into designs and into our new building construction. So here we're seeing, I think this project there was 3 or 4 different kinds of metal cladding panels being implemented. You have insulated foam, you have composite aluminum skin, you have some just like a surface metal cladding. This project I'll touch on a little bit later in the presentation. Again, mixtures of materials. This had fiber cement, had the aluminum composite, had granite, had precast. So becoming very, very complicated. Over here, this is a plastic composite panel, phenolic panel. Architects liked it because of the fancy colors and things like that that can be used. And then this one also is a project currently under design, under construction that I'm involved in, and I'll touch on that a little bit later too. So you can start getting all of these mixes of materials and the complexity in doing that. And this is what happens in reality, is when the architect doesn't necessarily think through a design perhaps, how an intersection comes together, when construction project sequencing doesn't go quite right. One sub can get there these weeks and another one can't until later, and really in the proper sequence of things they should be flipped. So now some things get done and then the other guy comes into play and can't properly flash something, can't get his materials behind others or whatever. That becomes a problem. Again, rooftops, walls, sheet metal work, flashings, and materials all coming together. Very difficult, and oftentimes the contractor ends up just throwing their hands up and getting the caulk on and doing their best. But it will come back to bite you. With this metal panel project, very modular. When you get insulated foam panels, for instance, those are not easily field modified to fit the condition. They're factory made. They show up on the site and they're just meant to be hung in place. Well, when you get a window opening that is framed in a little bit askew or something, all of a sudden now you are having to potentially field cut that panel and make modifications to something that, again, is going to compromise the integrity down the line. Again, just the things that happen. This is an air barrier situation, let's say where you've got steel structure that's being encapsulated, you've got a pipe connection of some sort coming through, and again, very difficult to properly put together. So the impact of these things, well, as you guys probably all know, the building tenants, the person whose office is behind that problem, we got water sitting on their stool, in front of their desk. We've got water leaking in above head of window, starting to collapse the drywall bulkhead there. See water, getting in a window in there as well, and bubbling paint. And in this one, maybe a little hard to see, but there's actually, this is a canopy, a pool of a YMCA that we did. And the thing was not sealed properly at the wall line. And this was winter time, and all of a sudden there are icicles dripping out from below. So, water's getting in there. Anytime you have water in spaces that aren't ventilated, and not, you guys all know what happens. You start getting mildew, mold, and also you have air quality risks and that kind of thing. So all of it becomes a problem. The other thing that we have to consider is when these things go bad, there's an inherent huge cost, basically, to get back there. So, you have to drop a swing stage off the side of the building. You have to scaffold and fix masonry issues. You have to get lifts in. You have to block off entrances. You're getting cranes in places that are not easily accessible, because of the reaches and things that you're dealing with. So again, much better to get it done right in the first place than to have to go back and do it. But obviously at some point, there's always, things that Mother Nature turns bad on us. Additional complications, after your building's built, I looked over there and same thing, cell towers get installed, the other equipment, security cameras, modifications are being made to buildings all the time, and oftentimes not with a lot of thought to resealing the building envelope properly after you're making penetrations, you're hanging stuff on. In addition, you're just making it harder for that roof replacement down the line, or to fix issues on a wall, because these things are being installed. So again, driving the costs up if it's not properly done in the first place. So issues that can happen. This is a courthouse job that we were involved in, kind of historic. At first blush, the stonework here did not look in too bad a shape. They had at some point, like 20 years ago, replaced the ledge. So again, I'm looking out at that building, very similar. But they were having leak issues, and we were brought in to basically evaluate where's this water coming from. And when you get up close, it's very easy to see that the mortar joints were starting to fail. Water was able to find its way in, and when we stripped away this beautiful looking stonework and everything was covering up this. Again, it was really just backup. It was, the structure. So there was not a lot of care taken in how this backup brickwork was installed. It was put around and through steel members and that kind of thing, and then pre-cladding was put on over the top. So again, did not look bad in the first place, but we ended up basically tearing down most of that parapet cladding down to the ledge and redoing it, putting a new through wall in, fixing the backup to the extent possible, and putting an air barrier or waterproofing membrane essentially in behind, so that if anything did get through the stone, then it would be able to weep out. Brick masonry, obviously, again, this is probably what most people are used to seeing, but over the years, there are movement issues that result in cracking. That oftentimes should be evaluated in terms of, is it a missing control or expansion joint in the veneer? Is it structural shifting that is occurring, since it was built? Sometimes just age. Masonry tends to move over time if it's not tied back correctly. In this case, unsupported brick masonry actually has a fair amount of movement potential in it. Efflorescence, this is oftentimes a first indicator of something going on. I'm reminded of a project we did last year down in Illinois, and it was portions of the veneer that we were removing and rebuilding because it was shifting and the mortar joints were bad. Again, the backup wall, kind of like the previous slide, was in this case just more or less CMU rubble that was, some blocks turned up vertically and just kind of patched around in there, so the veneer didn't have a great deal of support in its own right. But then after we fixed it, there still isn't a vapor barrier or a waterproofing membrane on that backup wall that would prevent interior air from coming out. So that in this case, that's a very good likelihood that there is just air and moisture traveling from inside out and exemplifying itself on the surface that way. This is a good case of previous tuck pointing where the mortar wasn't correct or it wasn't done deep enough or whatever, and it's basically just being kicked out of the joints again. So that's another thing that happens over time. It's not maintained correctly. Eaves and stucco, as we get into sort of the cheaper constructions. Oftentimes that goes through the whole construction sequence and everything. In this case, this is a good example where they didn't even bother to put a top flashing on it. They basically just wrapped it and caulked it into the brick, and you see water and snow sits on that, penetrates, and you start getting staining, flaking of the surface, spalling, that kind of thing. Oftentimes sealants go in these systems fairly fast. That's a major mode of failure for eaves, is sealant failure, and then water gets behind them and it just kind of snowballs into a larger problem. This was a couple months ago. We had a client had a building out in Honolulu, and strangely enough, I was the fourth choice to be able to go out and take that trip. 3 other people declined. And one of the biggest problems is when they redid they did a coating on the roof surface and basically covered up the weeps of the wall, the flashings at the bottom. And that was the one that had all the cell tower equipment and everything on it. Again, water penetrating up here, getting behind that eave surface, and going down, not being able to go any further. It's just another example of it coming out, and basically the surface starts failing, and then you have more problems as you go. Metal panels are becoming, as I said, one of the architect's favorites, depending on what kind you have. And there's all sorts of issues that can come up with metal. First, if there's a darker color like that, fading becomes an issue. It starts looking kind of iffy, especially if you have to do any replacement of pieces. In certain corrosive environments, you can actually have panels that, you know, start to corrode and fail that way. It's not a great system to have at grade level. Obviously, snow and ice and clearing salts don't like metal. And then oftentimes we see it on penthouses where people punch all sorts of louvers through them, doorways for access to the roof, mechanical pipes and everything else that kind of come through it. So you see an example of those. And again, very hard to properly seal when you have, you know, metal corrugations and, you know, different corner shapes and everything else. It's really should just be for shedding water, and it's being forced for architectural fashion reasons oftentimes into this one, and cost too. I mean, sometimes you know, it's so much cheaper to just pick a different material, a lighter weight material that you can use on a rooftop. Windows and curtain walls. These are very difficult oftentimes because it's sort of a, once it goes in, nobody else touch them again. And oftentimes when they went in, they weren't done correctly. This one in the upper left was a university building that every window on there was basically stick-built windows, and none of them had the proper end dam flashing at the edges of the opening. So from day one, they had water coming into the wall along the floor lines near these. And we ended up having to, we did a test removal, basically deconstructed it in one opening and found this out, and then came up with a way to basically put a new metal flashing frame around the thing and then reinstall it with leaves and everything. This is a good example of a bottom sill of a curtain wall against stone. Everything was great except that at some point somebody came along and sealed over all the leaves. Trying to chase a leak problem or something, sealed it up, and it just makes the problem worse as it goes forward.
They did that in Dodge County's courthouse. Yeah, instead of sealing under the flashing, they sealed over the flashing. So you had an air gap at the bottom and all the water dammed up in the window. Great end dams, they don't hold all the water in.
Correct. We see a lot of that. This is an example where they actually did, this was a 3-story curtain wall, and rather than pulling the snap caps off and dealing with the gasketing problems and open problems with the seal joints, let's say inside, they